now let's look at the detail of the MAC header field detail. So in MAC header, you will have a three component, what we call the frame body, which is coming from the upper layers. So then as we discussed last time, in the layer 2, you need to add the wireless header. So this is the main focus of this lesson. We will go into detail of all individual field available in the MAC header. But in general, just remember wireless frame has a header component. Addition to that, we will have the frame check sequence, the OCRC. So these are the three components. So now what's the LLC layer? What's the coming? What we call is a service data unit. Because it is MAC layer, we call it is a MSDU. So once we adding our MAC headers and trailers, the entire wireless frame is called MPDU, MAC protocol data unit. So now let's go into see the detail of what's inside the MAC header. So as you can see in the diagram, there will be a frame control field and then duration ID field, and there are 4 addresses field, and then the sequence control, keywords control, and HT control. So those are the main component. So let's look at the what's inside the frame control field. So in the frame control field, it is a 2 byte value. The first 2 bit is called the version bits. So in wireless, almost like the most until the recent amendment for 11AH, so only the protocol version 0 being used. So in that way, in normal Wi-Fi, you will always see the version number 0. But if it is sub 1 gig, there are some other version of frame type introduced that's called protocol version 1. So sometime if you read in the 2020 IEEE standard, you will see this reference PV0, that means protocol version 0. That means all the Wi-Fi frame which we know of. But if it is sub 1 gig, they introduce this protocol version 1. So just keep an eye on that protocol version field. But in the all wireless what we are discussing, always that field will be 0. So then we have within that frame control, first 2 bit is the version field, and there's something called type and subtype. So there are 2 bit field called type. That's 4 possible values. So that's why we said in the wireless there are 3 main categories of frame, like a control management frame, control frame, and data frame. So management frame always type value 0, type value 1 is control frame, type value 2 is the data frame. So those are the 3 main type of frames which we'll be going to discuss in the further lessons in detail, but keep an eye on the type value. So then even we saying management type is type 0, there are subtypes, like different number of management frame subtype available. So that subtype field is a 4-bit value. So that means you have a 16 different subtypes. So now in wireless, as the different amendment comes, they are adding different management frame types. So to do that, actually they define something called special type of management frame, what we call action frames. In that way, they have one sort of subtype defined as action frame, and then within that action frame, they have a different categories of frame. Sometimes we use for fast roaming, QoS. So we will talk about that special type of management frame called action frame. So we are being used because requirement is that 16 is not sufficient. So how they do it, they have one subtype of action, and then within that action frame they have a different categories. So then next one is actually 2-bit value, what we call 2DS value, and from DS value. As the table indicated, this is indicating the direction of where the traffic going or where the traffic coming from. If it is a data frame, all control and management frame, this bit set to 0. So that means this is not going to the distribution system. So that way, keep that in mind. All control and management frame, the 2DS and from DS bit 0, but all the data frame, it has to be either if it is coming from the wired side, from DS bit set to 1. If traffic going to the wired side originated from the wireless client side, to DS field set to 1. There's a special scenario where you will see both value become one. So that is typically in a wireless bridge or mesh environment. You will have this kind of both bits set to 1. So then there's a 1 bit value called more fragment. Like sometime in wireless frame you can do fragmentation. So if you do fragmentation, then the receiver need to know there are more fragment to follow before they reassembling the frame coming. So in that way, if this bit set to 1, that indicating this is a fragmented frame. So you will be see more fragments coming after that. So then there's something called retry bit. In wireless, as we discussed, it is a collision avoidance mechanism. It is impossible to have the zero collisions. In that way, wireless medium, you always see collisions. Like that mean what happen if it is a collision occur, you have to retransmit the frame. So to indicating this is a retransmitted frame, you will set this bit to 1. In that way, receiver, everybody know this is a retransmitted packet. Receiver also can identify this is a retransmission of a frame. And then there's something called power saving bit, like a PS power management bit. So this is in wireless, it's always important to client devices preserve their battery life, like a wireless. So how do they that actually, unless you are transmitting, you basically go into most of your radio chain will be power down, and only one radio chain you will be listening, what's happening in the medium. So in that way, unless you are transmitting or receiving your traffic, you don't want to activate all your receive chains. So now what most of the station will do, they will basically go to a mode called sleep mode. In that way, they will not do any activities only other than the sense in the medium using one radio chain. So if you are going to the sleep mode, you need to tell access point, hey, I am going to sleep mode. In that way, if access point receive traffic for this particular client, they can buffer the traffic. So in that way, the most of the time, like a client will be go to the sleep mode, and they will wake up for a beacon just to see whether AP got the traffic for them. In that way, periodically they wake up. So then once they wake up, they can inform AP as long as they see the beacon frame and understand AP indicating this client has traffic. So then client need to tell AP, hey, I'm wake up, please send me the traffic. So in that way, if the power save bit set to 1, that means you are going into the sleep mode. If a power save bit 0, you are saying that you are awake, you are ready to receive the packet. So that way, normally in the legacy method, like they use something called PS poll frame just to indicate if you set the power save bit to 0 and send, telling that AP, I am awake, you can send me the traffic. And then if you are finishing the traffic, receiving traffic, and then you want to go to sleep mode, you are sending the PS poll frame to the AP, setting the power save bit to 1. So with related to the power save bit, again there's another field called more data bit. So normally this is set by AP. For example, if AP client saying that client is happy to receive the traffic, and then AP basically sending the traffic to the client, and better whenever AP sending the frame, AP has more frame to send to this particular client. So in that way, more data bits set to 1. In that way, client know this is not the last frame. I have more frame to receive from the AP, so I should basically remain awake, like awake. So like that, more data bit set to 1, just to indicate you have more traffic, normally done by the AP. And then another bit called protected bit. This is just to indicate whether the payload traffic being protected. Like if you are implementing any security like WPA, WPA2, WPA3, those kind of protected data frames, this bit set to 1 to indicating payload is protected. Again, if it is a protected management frames, you can set this bit to 1, indicating the payload part is the protected. And there's a strictly ordered bit, like this is the traditionally using for particular service class, but actually this is not being used in that purpose anymore. So what this particular field is used, actually indicating a presence of the HT control field. So that way, there's another field in the wireless MAC header, something called HT control field, but just to indicating whether that field is present or not. So we are using these order bits just to indicating HT control field is there or not. But it was developed for legacy purposes, but that is not being used for strictly ordered kind of traffic classes. So that is the frame control bit. So let's move into the duration field next. This is a very important field in the MAC header. Again, it is like a 2-byte value, that means 16-bit. But as you see, it says duration/ID. But most of the wireless frame, it is being used as a duration time value. But a special kind of frame like a PS pole, we are using a ID value instead of the duration. So even though it has a 16-bit, if the first 2-bit is 0, that means the duration value is less than 32,768, which is the 2 to the power 15 value, but if you put the first 2 bits 0, any other bit values, total value, or whatever the largest value you can create should be 32,767. So in that way, if the value is less than that indicating a duration value. So if it is a duration value, it is very important to understand what that tell. Duration value always tell to the station in the cell. So after the current transmission, after the current frame transmission, medium going to be busy for a certain amount of time just to complete the current frame conversation. So for example, in this diagram, I have shown the typical, RTS, CTS flow, before basically we transmitting a data frame to provide the backward compatibility protection that every technology client can coexist in the cell. We need to send some control traffic. We will go into the detail of RTS, CTS frame detail in the control frame section, but just to get idea, so these frames goes in the legacy data rate. That means anybody in the cells can demodulate those frames. So that means anybody can read the duration value of RTS, CTS frame. But sometimes data frame may go in the higher data rate, like 11AC, 11N. So then if a client exists in 11A, he cannot read the duration value of the data frame. So in this way, the important thing to remember is what is the duration of RTS frame. It is the time taken for the CTS frame, data frame, and acknowledgement frame, and the interframe spaces you need to maintain. That's the total time of the RTS frame. So it's always after the current transmission. It is not talking about current transmission. So current transmission, if you want to get the duration value, so that can be done using the 5-layer component, because we have a 2 special value, what we call length and rate. By using those values, we can work it out the current data frame transmission time. So now we said if the value is less than 32,768, that representing a duration value. So now one special case, if these first two bits set to 1, then it representing a AID value, association identifier value. So this is being used in the PS pole frame. So we discussed earlier, if client want to tell, hey, I am awake or I am going to sleep mode, client need to tell this is my AID value. So that's value will be filled in here, and then first 2 bit set to 1. So AID value will be maximum, AID value is 2007. So in that way, just remember association identifier value goes from 1 to 2007. For the wireless client associate to the cell, AP will be giving an ID, that is the identifier. So that value will be 1 to 2007. So if AID value 0, it's a special value. Normally you cannot assign for any station, you cannot give to any station. So if it is a AID value 0 mean, that is actually not intended to any unicast client. So sometime when traffic is broadcast or group address traffic, we specify AID value 0. That means every client know this traffic need to be received because it is a group address traffic. So now when we look at the address field, as you can see in the MAC header, there are 4 address fields. But out of those 4 address field, all the frame will not have those 4 unique address field. So that's one important thing to remember. So sometime you will see multiple address field, but sometime receive address same as the destination address. So like that, 2 field will be common. So in that way, the keep in mind there are 4 possible addresses in the MAC header, but the address field 1, which is called receiver address. So this address present in all wireless frames. So in that way, that is the one address will be there in all frames. That is an important aspect to remember. Address field 2 we call transmitter address. So transmitter address is there in every frame. There are 2 exceptions. What is called acknowledgement frame and CTS frame. So in that way, CTS frame and acknowledgement frame, you only see the receiver address field. So that's one important thing to remember. So transmitter address will be there in all other type of frames. So address field 3, it's again depend on like couple of things. Sometime what comes in address field 3 determined by whether it is traffic coming from the DS going to the DS, or it is a aggregated frame, or it is just a MSDU. That means single MAC services data unit. So this is present in management and data frames only. Control frame does not have address field 3. So if it is a management frame, always address field 3 is the BSS ID. That is the MAC address representing that particular SSID. So that is the field in the address field 3 in the management frames. So address field 4. So sometime there are corner cases where you can see the 4 address field presence. So the most common one is wireless bridge connection. So in that way, or mesh connection. In that way, source and destination will be 2, and transmitter and receiver. Transmitter can be one side of the bridge network. Receiver can be the other side of the bridge network, wireless bridge. But source and destination is 2 different MAC addresses. So in that way, wireless bridge or mesh scenario, you will see the all 4 addresses present, and 4 addresses will be unique as well. So that is about the address field. Let's move into the what's in the sequence control field. So in the sequence control field, again it is a 2-byte value. So out of that 2-byte value, the first 4 bit we call the fragment number, and then the second part of it, 12 bits, we call the sequence number. So why it is important? Just to preventing replay attack, those kind of security concerns. So how we preventing is every station or every wireless communication, they will use a sequence number. In that way, we know is this coming out of sequence, or if somebody replaying a previous sequence traffic. So important thing to remember is if a wireless frame is fragmented, then we will have a fragment number as well. Otherwise, if it is unfragmented traffic, we will have the fragment number always 0, and then you have a sequence number. So the sequence number will be incrementing unless it is a retransmitted packet. If it's a unique transmission, then we are basically incrementing the sequence by each side of the conversation. So now in sequence number, if it is a fragmented traffic, sequence number remains same. Only the fragment number will be incrementing, and then by using that more fragment bit set to 1, then indicating more fragment to follow. Then the receiving device will wait for all the fragment to be received, and then reassembly. So then just remember the first fragment always start with 0. So if a fragment number 0, sometime it could be a unfragmented traffic as well. So now let's look at the next, what is in the QoS control field. We will be going to detail in the QoS later lessons. Later module will specifically have a module to talking about QoS, but in general here let's look at what is in that particular 2-byte. So the important field here is something called actually traffic identifier. So traffic identifier, TID, Again, it's a 4-bit value, but we will have a 3-bit called user priority. So then based on this user priority, you can have a 8 different traffic user priorities. So even though we have 8 different user priorities or UP value, you will have a break into 4 different traffic classes, or sometimes called access categories. So now if the user priority value goes for 0 to 7, so how we classify into 4, pretty much like, starting from the highest priority value 6 and 7, we call access class voice, and then 4 and 5 we call access class video. And ideally it should be 2 and 3 should be best effort, but as you can see here in the diagram, actually it is not 3 and 2, so it is 3 and 0. Why is that? Because if somebody is not marking the UP values, so wireless would like to treat that as a best effort class. So in that way, if it is a 3-bit value has been not set, that means 3 bits come as a 0, so you want to treat it as a best effort category class. So that's why in here 3 and 0, that's one thing to remember, we put into the access class best effort. So then 2 and 1 user priority values, we call it a background traffic. So in that way, priority point of view, voice is the first priority, video is next, best effort is third, and background is the lowest priority. Other than the UP value, in here, as you can see, you will have the acknowledgement policy, whether we are using the block acknowledgement, immediate block ACK, or delayed block ACK. You can specify which block acknowledgement technology we use, and then sometimes there's a 1-bit call AMSDU. So this is important in wireless analysis if you want to find out whether this frame is a aggregated MAC service data unit frame. So then by using this bit, you can filter the traffic. So we will look at that when we're talking about the frame aggregation section. And there's something called transmit opportunity, TX, like this transmit opportunity term as well, it is important. So normally we talked about in the introduction section how the medium access getting, like you basically need to sense in the medium. If nobody is transmitting, you basically counting down a value. When the countdown becomes 0, you basically getting the privilege to transmit. But again, once the frame transmitted, then again you have to go back to that contention mechanism and pick a random value and count down and wait for until the countdown becomes 0. Just to prevent that, if you want to give an uninterrupted opportunity for station to transmit, they have defined something called transmit opportunity. So in that way, that transmit or TXOP limit, that field is a 8-bit value available in the QoS control field. So in that way, if station want to let AP, this is my traffic buffer, so I want opportunity to transmit, they can specify their TXOP limit depending on how much data they have transmit. So we will talk about all this particular field bit more detail in the QoS section. At least in here, just remember what is in the QoS control field. The important thing to remember, this QoS control field presents in the data frames, QoS data frame. It is introduced with 11E in 2005, classifying traffic into these 4 classes. In that way, it is only available in the QoS data frame, not the legacy data frame. It does not have this kind of QoS control field. The other thing, that transmit opportunity value specify in certain time unit. 32 microsecond is a one time unit. So if it is a 100 time unit, that means you got a 3200 microsecond or 3.2 millisecond transmit opportunity. So now let's look at what is in the HT control frame. Again, as we discussed, this is available, just to basically convey certain phi and MAC layer characteristics, to communicate, you can use that. So now, as you can see here, this first bit, this actually introduced with this HT control feed with 11N in 2009. So at that particular time, there was a not 11AC, 11AX they talked about, just to had a 1 bit to indicate bit 0. If it is a bit 0 value 0, you indicating the HT control field is there, and then basically some other PHY and MAC layer field values can be incorporated into this HT control middle, whatever the information can be embedded. Whenever 11AC and 11AX come, so they wanted to basically keep using this, but they didn't have a separate control field added. Still they use the HT control field. What they are doing is actually just to differentiate. If the first bit become 1, it has to be either 11AC or VHT or 11AX or HE. So you can read the 11AX amendment to get all the detail if it is your need to know about what information going in the 11AX frame in the HT control side. If it is a VHT, again 2020 standard is the document you should refer. So now in the last bit in this particular lesson is the frame check sequence. So now frame check sequence is providing the 32-bit value, the cyclic redundancy check. In that way receiver can validate whether the frame has been received correctly. So in that way, it is a kind of integrity check, like we will validate whether frame has been corrupted or not. If it is corrupted, then receiver will not acknowledge. In that way, it will be retransmitted by the transmitter. So like that. So this is the high level, all the field of the MAC header and trailer part as well. So now what we do is next we will go into the we talk about 3 different type of frames, so now what we're doing is actually starting from the management frames and then go to control frames and data frames and go deep into the different type of frames. So let's go to the management frames next.